I'm the last, so I promise I'll be quick and effective. But first of all, I would like to thank you, the organization of the Coating Forum, for the kind invitation, and also Polytrade, with our partner here in Greece. First of all, who we are. I'm Mirko Zago. I'm responsible for the R&D of ASTROBIO green solvents in Soft Chemicals. Soft Chemicals is a small-medium enterprise located near Malpensa Airport, so in Italy. And it was founded in 1995 as a company specialized in the production of auxiliaries for textiles application, chemical auxiliaries, of course, because we are all chemists. And later on, also in the design and manufacturing of sustainable solvents blends, which is what I'm working for, what I'm dealing with. Here are some of our numbers, just to give you an idea of who we are. And first of all, since 2006, what we do is to help and encourage the transition of companies from a polluting chemistry based on the refining of fossil resources to a green chemistry based on the conscious use and enhancement of renewable natural resources. How we plan to do that? By, of course, designing and producing less toxic solvents, specifically sustainable solvents, for humans and the environment, that are capable of replacing in many industrial applications, not all industrial applications, otherwise it would be a magic trick, some of the most widespread and toxic fossil-based molecules like aromatic solvents, paraffinic solvents, and so on. But what I like to highlight in this first part of my presentation is the link between why sustainable raw materials are so important, why there's a lot of hype between sustainable raw materials and climate change. Because, of course, maybe those are things that all of you know very well, but I find it sometimes it's very useful to remind it to ourselves and to me too. So 2024 was the world's warmest year on record, and for more than half of it, average temperatures were more than 1.5 degrees Celsius above the baseline. And climate change, guys, is real, and we are seeing its effect every day and everywhere, and billions of dollars are now being spent, not tomorrow, not in the next few decades, but now, to fix climate change, social and environmental disasters. But ultimately, climate change comes down to one single number, which is the concentration of carbon in our atmosphere. And as you can see from the graph, for most of our history, for most of the human history, these numbers has bounced widely between 180 and 300 ppm. And we did also global temperatures, as you can see from the video on the upper right. And this was really a hard time that allowed only the survival of man and not the development of a thriving society. But finally, almost 10,000 years ago, something strange happened. So this number has stabilized, allowing us to, and finding ourselves in an unprecedented period of climate, reliable season, and predictable weather, okay? But now, as we all know, things are changing, and do you know is the fault? Our fault. So this was the value at the beginning of the last century. This was the value in the 60s, and this is the value today, guys, 426 ppm. And this is due undoubtedly to our burning, and this is causing what you are seeing here in the video. Here you are seeing the global average temperature variation between 180 and today, basically. Red color, of course, are temperature higher than the average. And as you have seen, practically in the last 25 years, we are hotter than the average practically everywhere on Earth. And this is due to our burning of fossil fuels, our destruction of nature, our approach to industry, and our approach to building and constructions. Those kind of things are releasing carbon to the atmosphere at an unprecedented pace and scale. So what do you think? Is this how our story will end? We will burn in fire in a few decades and stop? I don't think so. And perhaps the fact that young people alive today, and also less developed countries, are suffering from the dangers of climate change, and basically they do not so much fault about these kind of things. Maybe this will give us the momentum to rewrite our history, because now we understand this problem, and after all, we are the best problem solvers as human species, of course, that ever existed on Earth. And now we know what to do. We need to stop dumping greenhouse gases emission into the atmosphere, and we need also to recover billions of tons of CO2 from the atmosphere. And one of the things manufacturing companies can do to fight climate change right now, from today, also from yesterday if you wish, is to start using sustainable raw materials. Why? Because energy transition is not enough. As you can see from the graph, almost 45% of the overall global greenhouse gas emissions are caused by industrial manufacturing, so by the production of all the products and the food that enable our modern lifestyles. And solvents are produced at scale every year, at scale meaning millions of tons, to manufacture those products. So finally, why bio-based raw materials are so important? It's mainly a question of time. Bio-based and sustainable raw materials in general, not just bio-based. Because carbon dioxide is fixed into organic molecules and used to produce chemicals, and the same carbon, of course, green carbon, will be released at the end of the chemical life cycles without increasing the atmospheric CO2 concentration, okay? Fossil-based chemicals, on the other hand, are produced using fossil carbon, black carbon, which was preserved underground over geological eras. And at the end of the life cycle, they will release this additional CO2 to the atmosphere. So what does that mean? Very simply, forgive me if there's an SCA technician on the show, but I'd like to say it in very simple words so anyone can understand. So this means that bio-based raw materials comes with a carbon credit that has to be subtracted from their overall carbon footprint if you're considering their overall life cycles. While fossil-based raw materials comes with a carbon debit that has to be added to their overall carbon footprint when you're considering their overall life cycles. So what is clear to me, and what I hope is clear also to you after this presentation, is that we are living in a transition phase. So an increasing number of bio-based molecules are available, but sometimes they show some technical limitation, like, for example, in a coating formulation. So limited solvency power towards polymers or resins, evaporation rate too high, too low, compatibility problems, and so on. We were able to find solutions to these kind of problems with the use of solvents blend. So we are truly capable of implementing sustainability in sectors like coating, in which could be very difficult to do it, at least when we're speaking about solvents. Okay. So what we do basically is that we are able, all our products are designed to match physical chemical properties of fossil-based solvents. This means, for example, that our ASTROBIO XT, which is our replacement for xylene and toluene, is able more or less to mimic solvency power, evaporation rate, flash point, surface tension, and so on. But what must be important also, behavior in formulation. We are not so precise, of course, because in our replacement there's not a single molecule, there's not a single mole of xylene, for example. But we found that in industrial practice, we are more than enough to stop using a toxic and a fossil molecules and start using a more sustainable one. This is some example. In the first graph, you can see the percentage of solvents added to a given amount of resin. On the horizontal axis, the percentage of solvent added to a given amount of resin. And on the vertical axis, the viscosity of the solution thus forms. And as you can see, we can see also sometimes improving behavior. So at lower concentration of solvent, you can see that the blue line is our replacement for methoxypropanol, of course. We have a lower viscosity. So for example, you can use less solvents and obtain the same viscosity. It's just an example, of course. All this thing has to be tested. And here are other examples, surface tension, as you can see, and flash point, the values are more or less the same. And finally, what we do, we are also involved in a research project that, whose aim is, of course, to finding novel and more sustainable ways of producing existing molecules. Like, for example, this one, that arose from a cooperation with the University of Milano Bicocca, from which we are close. We invented a new way of producing small esters, like ethyl acetate, butyl acetate, methyl formate, and so on, molecules that are widely spread used in the coating industry. And what is interesting about this technology is that we use mild condition, and esters are usually produced with extreme heat, pressure, corrosive catalyst, and so on. In aqueous condition also, with an intrinsic regeneration pathway of the cofactor, which is an enzymatic reaction, and that yields higher than 100%. This may sound strange if you're a chemist, but there's a very good reason I would be glad to explain if you are curious. Of course, it's a patent pending application. We filed the patent application in last year. So this is basically one last thing. We are quantitatively more sustainable because here you can see just an example. ASTROBIOSOLVENT, which is our replacement for N-methyl pyrrolidone. As you can see, global warming potential, we are cradle-to-gate. Those are cradle-to-gate data without considering the bio-based content. So cradle-to-gate data. We are more than half when we are compared to NMP regarding carbon footprint. So thank you.